Welcome back to our series on AI and machine learning. In this lesson, we'll explore the crucial process of data preprocessing. Properly preparing data is essential for building effective machine learning models. We'll cover data collection, data cleaning, feature selection and engineering, and normalization and scaling. Let's start with data collection. Data is the backbone of any machine learning project, and collecting it is the first step. There are various methods to gather data, including surveys, sensors, and web scraping. Surveys are often used in social sciences and market research to collect responses from people. Sensors are used in fields like environmental monitoring and healthcare to gather real-time data. Web scraping involves extracting data from websites, which can be particularly useful for gathering large data sets from the internet. Once we have collected the data, the next step is data cleaning. Real-world data is often messy and incomplete, so we need to clean it to make it usable. Data cleaning involves handling missing data, correcting errors, and removing outliers. Missing data can be addressed by either filling in the gaps with estimates or by removing incomplete records. Correcting errors involves fixing inconsistencies and inaccuracies in the data, such as misspelled words or incorrect entries. Removing outliers, which are extreme values that differ significantly from other observations, helps prevent them from skewing the model's performance. After cleaning the data, we move on to feature selection and engineering. Feature selection is the process of identifying the most relevant features or variables in your dataset that contribute to the model's predictions. This helps improve model performance and reduce complexity. Feature engineering, on the other hand, involves creating new features from existing ones to better capture the underlying patterns in the data. For example, if you have a dataset with a date column, you can create new features like the day of the week, month, or year to help the model better understand temporal patterns. Next, we have normalization and scaling. These techniques adjust the data to a common scale, which can significantly improve model performance, especially for algorithms that rely on distance measurements, such as k-nearest neighbors or support vector machines. Normalization involves transforming the data to a range between 0 and 1, while scaling adjusts the data to have a mean of 0 and a standard deviation of 1. These techniques help ensure that all features contribute equally to the model, preventing any single feature from dominating due to its scale. To summarize, data preprocessing is a critical step in the machine learning pipeline that involves several key tasks. Data collection gathers the necessary information using methods like surveys, sensors, and web scraping. Data cleaning ensures the data is accurate and complete by handling missing data, correcting errors, and removing outliers. Feature selection and engineering identify and create the most relevant features for the model. Finally, normalization and scaling adjust the data to a common scale to improve model performance. In conclusion, properly preprocessing your data can make a significant difference in the performance of your machine learning models. It ensures that the data is clean, relevant, and appropriately scaled, setting a strong foundation for building effective models. In our next lesson, we'll delve into the different types of machine learning algorithms, exploring how they work and when to use them. Stay tuned